Continue mechanics, a review of the mechanics of rigid bodies. A uniform rigid rod, AC, of mass 2 kilograms and length 120 centimeters hangs at rest in equilibrium with its end A against a rough vertical wall. The rod is kept in equilibrium by a light string of length 70 centimeters, which has one end attached to a point B on the rod, 90 centimeters from A, and the other end attached to a point D on the wall, 140 centimeters above A. Given the lengths of the line segments AD, AB, and BD, use the cosine rule to determine the angle ABD. Then use the sine rule to determine the angle A and use the sine rule to determine the angle D. If a horizontal line is drawn through the point B on the rod that meets the wall perpendicularly at the point E, then the angle EBD is equal to 90 degrees minus the angle D. Now construct a right-handed rectangular coordinate system through the point A. This means that we take the point A to be the origin of the coordinate system. Note that for convenience, the x3 axis is not shown, but should be taken to be normal to the plane containing the x1 and the x2 axis. With respect to this coordinate system, let F1 be the force due to the wall that is acting on the rod at the point A with position vector x1. The force F1 has two components. The first component is the normal reaction of the wall on the rod. The second component is friction, which prevents the rod from slipping down the wall. Let F2 be the force due to gravity. By symmetry, this force will act at the midpoint of the rod which has position vector x2. let F3 be the force due to tension T in the string that is acting on the rod at the point B with position vector given by x3. Given that the rod is at rest in equilibrium, we must have that the sum of the forces is equal to 0, from which we obtain the following two equations. Furthermore, the sum of the moments of all the forces with respect to the point A must be equal to 0, from which we obtain the following equation. If we take the acceleration due to gravity as 9.8 meters per second squared, then we can solve the system of equations and determine the magnitude of the normal reaction of the wall on the rod, the tension in the string acting on the rod, and the coefficient of friction rounded to 3 decimal places.